The last 2 years have taught us many things, including the fact that disruptions, sometimes of enormous scale, are becoming increasingly frequent. Many of the key disruptions over the last 2 years also had tremendous impacts on the dairy industry. For example, substantial amounts of raw milk had to be dumped during the COVID epidemic. In addition, there were widespread issues with availability of dairy products at retail early in the COVID pandemic. But these types of disruptions are not necessarily something new to the dairy industry. Power outages and natural disasters, such as massive snowstorms, have always disrupted dairy operations in many parts of New York. Stakeholders across the dairy value chain, including producers, processors, retailers, consumers, and regulators, need to respond to disaster situations rapidly. Decisions often evolve around whether raw milk exposed to temperatures above the legal requirements or stored for extended time periods can still be utilized to make safe and high-quality products. Similarly, decisions may also need to determine whether finished products, such as HTSD milk, yogurt, etc., stored at temperatures above the legal requirement and/or for extended time periods, can still be shipped to consumers. In the past, these types of decisions were typically made by experts, who may or may not be able to respond in a timely manner, and in some cases, may not have the expertise needed to make proper decisions. This project will develop a better and more accessible way to allow the New York dairy industry to rapidly and more reliably make decisions during disruptions and disaster scenarios. We specifically propose to develop a computational New York farm-to-consumer dairy supply chain model. This model will allow for prediction of dairy product quality and safety characteristics under a baseline scenario using typical data from New York raw milk quality and supply chain characteristics in non-disruptive conditions, as well as different disruption scenarios. The final models will be distributed and made available as both an expert tool that experts can modify and run on their own computers, as well as an easy-to-use online tool. Importantly, development and distribution of these tools will also allow the dairy industry in New York to stay competitive with other food industries who are already developing these types of tools, which are often called digital twins. Ultimately, these tools can also be modified to optimize and continuously improve dairy supply chains. Finally, this project will also help position the New York dairy value chain as a leader in digital food systems, which can garner increased consumer trust, thereby increasing sales, particularly to technology generations and Gen Z.